Okay, Bismillah ar-Rahman ar-Rahim. We'll continue with these problems. Let me do 51 first. What is 51? It's this one. 51. Okay. So what's the domain of f? I have x is positive. Okay. Now let me check f prime. F prime will be what? 1 minus 1 over x ln 4. Okay, critical numbers. I check f prime equals 0. So I have what? 1 minus 1 over x ln 4 equals 0. That means I have x ln 4 minus 1 equals 0. So I have x equal 1 over ln 4. Okay, so this is a critical number. Now, I'll put this one. This is 0. This is 1 over ln 4. Okay, now check the signs now. Okay, so I need to take values. If you notice, 1 over ln 4 will be greater than 1 over ln e. Is it? No. It's between what? Not ln 4. Ln 4 will be greater than ln e and less than yeah, ln 4 is what? Ln 4 is a value. Ln 4 is between ln e and ln e square. Correct? Yeah, e square is greater than 4. So it means ln 4 is a value between 1 and 2. Okay. Okay. E is 2.7, so it's less than 4. E squared 2.7 square for sure is greater than 4. Okay. So that means what? So ln 4, 1 over ln 4 will be greater than half and less than 1. Yeah. Okay. So take a value, for example, half. What will be f prime at half? F prime at 1 is very clear. It's 1 over 1 minus 1 over ln 4, which is positive. So f prime at half, I take a value half here. Half somewhere. Here I take 1. Okay. F prime at half will be what? 1 minus 1 over half. That 1 minus 2 over ln 4. So it's negative. So this will be negative. So it's decreasing. Yeah. But f prime at 1 will be 1 minus 1 over ln 4. Ln 4 is something between 1 and 2. So this is positive. So this is positive. So it's decreasing, increasing. So it means the function is increasing or decreasing from 0 to 1 over ln 4, decreasing, and increasing from 1 over ln 4 to infinity. And they have local minimum at x equal 1 over ln 4. Okay. Now, let me go to 63. Yeah. What's the domain? Actually, he gave us the domain, what they want, this one. Yeah, the function is a little bit complicated, but I think we can do it by the calculation. Okay, let me do f prime. What will be f prime? Will be 2 square root 9 minus x squared, product rule, plus 2x, 2 square root 9 minus x squared, here minus 2x. So these two cancelled with this. So I have what? 2, 9 minus x squared minus 2x squared over what? Over square root 9 minus x squared. So that give me what? Yeah, I can take 2 common factor. I have 9 minus 2x squared over this. Okay. So f prime equals 0. That implies I have x equal what? Square root of plus or minus square root 9 over 2 over square root of 2. Yeah, which is plus or minus 3 over square root of 2, which is plus or minus 3 square root 2 over 2. Okay, now we'll do the interval. I have minus 3, I have 3, I have minus 3 root 2 over 2, I have 3 root 2 over 2. Now check the signs. Okay. Yeah. Okay. If I take a value here, what is f prime? This is my f prime. This is my f prime. This one will make no change about the sign. So my control is here. 9 minus 2x squared. At 0, for sure, it's positive. It will be positive. Take a value 0 here. There, take a value, for example, like what? Yeah, for sure, this one will be negative. If you take a value here between less than minus 3 square root of 2 over 2, that will be 0. So that will be negative. And this one will be negative also. So it's decreasing from minus 3, decreasing from minus 3 to minus 3 square root 2 over 2, and 3 square root 2 over 2, and 3. And increasing and increasing. This is decreasing, increasing, decreasing. Decreasing from minus 3 square root 2 over 2 to 3 square root 2 over 2. I think this is what they want. Just they want to find the intervals. Yeah, there is relative minimum minus 3 square root 2 over 2, relative maximum 3 square root 2 over 2. Okay, let me do more problems. Have x squared minus ln x. As I said, the same idea, but now the functions becomes complicated. Functions becomes a little bit complicated. Okay, so 69. He gave a specific interval from 0 to 3. What you will do, f prime will be what? Have x squared, that is x minus 1 over 2x. In other words, it's 2x squared minus 1 over 2x. Okay. Critical numbers. I have f prime equals 0. So I have what? 2x squared minus 1 equals 0. So I have x equal I have x equal 1 over square root of 2 or x equal minus 1 over square root. This is rejected. Why? Because actually, yeah, because of this. So the domain is starting from 0. And also the given interval, this is not in the given interval. So x equals square root 2 over 2. I can rewrite it as square root 2 over 2. Okay, that's the only one. So I have this is 0. And I have this is root 2 over 2, and this is 3. So I'll take a value between root 2 over 2 and to check this one. The sign of this. This is always positive because the values are positive values. 2x squared minus 1. Before that, take a value like what? Half, for example. Half will give you what? 2 times 1 over 4, which is half minus 1, that will be negative. Take a value here like 2. 2 will be positive, very clear. Or 1. So it's decreasing, increasing. So it's decreasing from 0 to square root 2 over 2 and increasing from square root 2 over 2 to 3. And they have local minimum square root 2 over 2. Okay. 70. What is 70? Now we need to do the calculations. That will be what? 70. He gave me a specific interval. خلاص. F prime will be what? Product rule minus 2x ax plus 4 minus x squared ax. That will be ax times what? 4 minus 2x minus x squared. So I have f prime equals 0. I'm getting this 4 minus 2x minus x squared equals 0. Okay, how to solve this? I cannot factor it, but I can solve it using the quadratic formula. So I have what? X equal minus b, which is 2. Well, let me rewrite it. It will be easier. X squared plus 2x minus 4 equals 0. So the solution minus b plus or minus square root b squared 4 minus 4ac plus 16 minus 4 times minus 4 times 1 over 2. So it will be minus 2 plus or minus 2 root 5 over 2. So the answer is minus 1 plus or minus square root of 5. But I don't want all of it, because x equal minus 1 minus square root of 5. This is rejected. I have only x minus 1. This is what I want. Okay. So call it C1 or X1. So I need to rewrite it. Okay. So I have from 0 to 2. And by the way, this is less than 2. So it will be somewhere here. This belongs to the interval 0 to 2. X1. Yes. So take a value before that. I want to check this function, f prime at x. I'll take a value. What is it? 1. Yeah. The square root of 5 is what? 2 point something. So it will be 1. 1 I can choose here. 1 give me what? 4 minus 2 minus x squared. 4 minus 2 minus 1, that will be positive. Yeah. Take a value here. What is it? Like 3 over 2? Yeah. Like 3 over 2 will give you what? 4 minus 3 minus 9 over 4, which is big number, so it will be negative. That will be negative. So it will be increasing. That will be decreasing. So increasing from 0 to This is strange number and decreasing. -1 plus square root of 5 to 2. Okay. Yeah, I think it's very clear. Now we'll have some general questions or questions, different ones. Compare the functions. Use symmetry extreme and 0 to sketch the graph of this. What I want from this, just you need to notice one thing, that these two functions are the same. These two functions are the same functions. How is that? Check f of x, except at a specific point. This is what they wanted to check. So I have what? Take x, I have x to the power 4 minus 4x squared plus 3 over x squared minus 1. And this will be x. This I can factor it, x squared minus 3 times x squared minus 1 over x squared minus 1. Now this can be cancelled, provided x not equal to plus or minus 1. So it will be the same. You can graph this, but I will leave it for you. But the point is, f of x is the same as gx when x not equal to plus or minus 1. So you can graph this one and just make a hole. There will be a hole at x equal -1 for g of x, for f of x. There is holes at x equal -1 at x equal 1. Actually, when x equal -1, what will be y? You just substitute at -1, it will be what? Yeah, just substitute here. It will be -1. That will be 2. At -1 and 2. And at 1, at -2. There will be a hole. So these two functions are the same. And I think you can graph this one easily. So I'll leave it for you. But this is the main idea. These two functions are the same, except at one point. Think about it. The graph is shown. Sketch the graph of the derivative. Sketch the graph of the derivative. Okay. I will just sketch the graph of the derivative for these functions. I want you to do what? Sketch the graph of the derivative of f. Okay. If you notice, before this point, which is 1, we can make it 1. Okay. Or -1, I mean, -1. The function is decreasing. So the slope is negative here. So until -1, this is f prime. Here, from -infinity to -1, from -infinity to -1, f prime is negative. Yeah, so it will be something like this. Since it's negative. Now, from -1 to 1, from -1, will be, the slope is positive. -1 to 0, -1 to 0. It's positive. So it will do something like this. Here -1, here is 0. It will do something like this. Then it go back to 0. From 0 to infinity, from 0 to 1, I mean, it will be negative. And from 1 to infinity, it will be positive. Talking about the slope. So it will do something like this. This is up to 1, then it will be positive. I can do it like this. From -1 to 0, f prime is positive. From 0 to 1, f prime is negative. From 1 to infinity, f prime is positive. That will be a sketch. It's just a sketch, huh? Just a sketch. Okay. Now 78. Let me do 78, the same idea. Here, the slope is always positive, huh? This one, you notice? Always positive. But you notice one thing. Here I have a vertical tangent. So the slope will reach infinity at this point, at 0. It will reach infinity in both sides. So the slope is going like this, increasing. Then it will go like this. It will start with a small value, where it will like going to 0. And then it will increase. This is this side. Always positive, but it will go to infinity. In the other side, it will go to 0. It goes for infinity, since they have vertical tangent here. I have vertical tangent here. Vertical. So this is, there will be a sketch for that graph. As I say, it is just a sketch. Huh? Okay. Exploring concepts. So these questions, what they said. Exercise 79, assume that f is differentiable, x, f prime is positive in this interval and negative in this interval and positive in this interval. So let me put the interval in front of me. So I have what? Up to -4. Okay. And from -4 to 6. Okay. I'm talking about the sign of f prime. So -infinity to -4, it's positive. Okay. -4 to 6, it's a negative. 6 to infinity is positive. خلاص. Okay. Now let me do 79. What do I want 79? 79, they want this function. What will happen to this function? Of x plus 5. So I have f prime. G prime will be what? Will be the same as f prime. No difference. That means what? G prime at 0 will be the same as f prime at 0. And they know f prime at 0 is here. So it will be negative. That will be negative. So this one will be negative. This one will be less than 0. Now we'll do 80. Same idea. G of x is 3, f of x minus 3. What will be G prime? Will be 3 f prime of x. What they want? They want G prime at -5 will be 3 f prime at -5. Where is -5? -5 is here. That will be positive times 3, so that will be greater than 0. So that will be greater than 0. Okay, 81. G of x is minus f of x. What will be G prime at x? Minus f prime at x. So it will be G prime at -6. It will be minus f prime at -6. Where is -6? Here. So that will be negative. Since f prime at -6 is positive, multiplied by minus, that will be negative. So that will be less than 0. Last one. G of 82. G of x, f of x minus 10. What will be G prime? Will be f prime at x minus 10. Okay, so it will be G prime at 0. G prime at 0 will be f prime at -10. Where is -10? -10 is here. So it will be positive. So that will be positive. I think it's clear. Let's get the graph of the arbitrary function. F prime is positive, -infinity to 4. And f prime is negative, 4 to infinity. And f prime undefined at x equal 4. Yeah, 83. We're going to graph a function like that. One way to do it for f means it's increasing here and decreasing there, and f prime does not exist at x equal 4. So let me say I have x equal 4 like this. It's increasing. This is decreasing. This is one example. Yeah. 84. Is it possible to find the differentiable function where f is positive, f prime is negative? Yes. Take this one. E is minus x, always positive. What is f prime? Minus e is minus x, which is always negative. So this is an example. Increasing functions. Consider the increasing function f and g. Is f and g always positive? Let me check. I have f and g increasing. That means what? F prime positive and g prime positive. Okay, what they want? F plus g. I want to check h. What will happen to this? Check h prime will be f prime plus g prime. But this is positive, so all of this is positive. So it means h is increasing. B. My h is what? F times g. So check h prime will be f prime times g plus f times g prime. I know this is positive, but I know nothing about these two. This is maybe positive, maybe not. So no conclusion. In this case, we say no conclusion. All the possibilities are there. So is always increasing? No. This is yes. But they mean no conclusion. I cannot decide. It is not always increasing. It's not always decreasing. All the things happen. Maybe it's not increasing or decreasing at all. Okay. 86. What they want. Use the graph of f prime. This is the graph of f prime to identify the critical numbers of f. The open interval in which f is increasing. Determine whether f has a relative maximum, relative minimum, or neither at each critical number. Okay. So, how to check critical numbers? F prime equals 0 or f prime does not exist. Okay. Increasing. F prime positive. Decreasing. F prime negative. Relative minimum, relative maximum, we know how to find it. But this is the graph of what? This is the graph of f prime. So 2 at a, huh? At x equal 2, I have what? Critical number. Since f prime at 2 equals 0. Before 2, so this is, like if give me this is 2. Before 2, f prime is negative. I have f prime negative. This is f prime negative. After 2, f prime is what? Positive. This is the graph of f prime. So I have decreasing, then increasing. So it's decreasing from minus infinity to 2, and increasing from 2 to infinity, and they have relative minimum at x equal 2. Okay. This is 1, 2. I have a space. 2. What will happen at 2? I have at 0 and at 1, I have critical numbers. Critical numbers, x equals 0 and x equals 1. This is and this. This and this. These are the critical numbers. Since f prime at 0 equal f prime at 1 equals 0. Okay. So if they put the number line, this is 0. This is 1. Oops. So I have before 0, the value of the function is positive. Between 0 and 1 is negative. F prime, I'm talking about f prime. This is the graph, and this is positive. خلاص. So this is means increasing, decreasing, increasing. So it's increasing from minus infinity to 0 and 1 to infinity and decreasing 0 to 1. And they have relative maximum, relative max at x equal 0, relative min at x equal 1. Okay, third one. Third one. This one. I have 1, 2, 3. 3 critical numbers. Critical numbers, very clear. X will be equal minus 1, 0, 1. I'll do the number 9, the same thing. This will be minus 1. This is 0. This is 1. Before minus 1, the function is positive. Between minus 1 and 0, the function is negative. Between 0 and 1, the function is positive, then it will be negative. خلاص. I can decide easily now. Increasing from minus infinity to minus 1 and 0 to 1, decreasing from minus 1 to 0 and 1 to infinity. Relative max, this is increasing, decreasing, increasing, decreasing. At what? At x equal minus 1 and x equal 1. Relative min at x equal 0. Okay, now let me do the last. What I have critical numbers 1. I have critical minus 3 and 1. Here is 1 and here. So critical numbers minus 3, 1, 5. X. Now we'll do number line. It's minus 3, 1, 5. Before minus 3, the function is negative. After that is positive. Between 1 to 5 is still positive. Okay. 1 to 5 is still positive. And after 5 is negative. So it's increasing, minus 3 to 1 and 1 to 5, 1 to 5, yes. Decreasing minus infinity to minus 3 and 5 to infinity. Okay. Relative is decreasing, increasing, increasing, decreasing. I have relative max at x equal 5. Yeah, at x equal 5. Relative min at x equal minus 1. Relative max at x equal 5. At x equal, relative min at x equal minus 3, sorry. Here. This is decreasing, increasing. At 1, we don't have nothing. We don't have any relative maximum, relative minimum. Okay. Analyzing a critical number. This is different questions, just to be sure you understand the idea. Okay. Differentiable function has one critical number. It has only one critical number. And define the relative extrema at the critical number where f prime at 4 equal minus 2, 5. It has a critical number at 5, 87. I have a critical number at 5. خلاص. So I have only one critical number. That's the only critical number. And before that, now checking the sign of f prime, I have 4 here. That give me minus 2.5. And for 6, I have 3. What do you want? I want the relative extreme at this critical number. Is it? Look, this is negative. So this is f prime will be negative. So this is the only critical number, means f prime should be negative there. And the function is differentiable. Huh? So this is will be increasing. This is positive. This is negative. So we have what? At x equal 5, we have relative minimum. 88. We have critical number at x equal to. Plus f prime at 1, which is here. It's f prime at 1 equal to positive. And they have f prime as 3. F prime as 3, also positive. And that's the only critical number. So I have increasing. So we have no relative extremum at x equal to. Since it's increasing. Okay, I'm almost there. I think we have only 3 problems to go. Okay, creating a polynomial exercise is this. Yeah, you are giving this function. He said the minimum degree. Yeah, since the relative minimum 0, 0, relative maximum 0, 0, 2, 2. So I have how many equations? I have, this is the point in the function. So I have f of 0 equals 0. And they have relative minimum, it means f prime at 0 equals 0. From here, I have f of 2 equal 2. They said the relative maximum, so I have f prime at 2 equals 0. So I have 4 unknowns. It means my function is this. A3x cubed plus a2x squared plus a1x plus a0. Because I have 4 equations, I need 4 unknowns. So that will be my function. And I think I did it before. We did it before somehow. Yeah. Where did we do that? I think we did it in one of the old exams. Yeah, recent old exams. Yeah, this is the question. So I will not do it again. I think you can do now. So I will leave it for you to do it again, or yeah. Oops. Where am I? Okay. Now let me finish true or false. This is true or false questions. And then the last question. There is no function with infinite number of critical numbers. The answer is false. Why? Take sin x. Sin x has infinite number of critical numbers. Okay. The function of x has no extrema in any open interval. 108. This is true. Why? Because f prime will be always 1, which is positive, and I have open interval. So there is no way I should have an extrema. There will be no change from positive to negative. Okay. Every n degree has n minus 1 critical numbers. 109. If I have polynomial of degree n, how many critical numbers we have? Is it n minus 1? No, this is false. Example, f of x equal x cubed is 3rd degree. But how many critical numbers I have? F prime equals 3x squared. I have x equals 0 is the only critical number. So 3, I don't have 2, I have only 1. Also, you can make it x to the power 100. We don't have 99 critical numbers, we have only 1. So this is in general false. 110. An nth degree polynomial has at most n-1 critical number. This is true. When he said at most. Why? Because if we have nth degree polynomial, n degree polynomial, this is f prime will be what? It will be n-1 degree polynomial, which has at most n-1 zeros. Okay, at most n-1 zeros. Okay, so this is true. 1, 1, 1 says what? There is a relative extrema at each critical number. No. The function may be not continuous at each critical number. No. And not only that, for example, x cubed. X cubed, take x cubed. I know that in f prime equals 3x squared equals 0. So x equals 0 is a critical number. But there is no relative extrema at x equals 0. Actually, more than that, if the function is not continuous, that will make it very clear. The relative maximum of a function are f of 1 equal 1, 4, and f of 3 equal 10. At least one minimum for each x in the interval 1 to 3. The relative maximum of the function f are f of 1 equal 4 and f of 3 equal 4. And the 1, 1, 2 in the function, where at f1 and 4, I have relative maximum, and f3 and 10, I have relative maximum. This is 1, this is 4, this is 3. This is 10. And I have relative maximum here. So it will do something like this. Okay. And then I have relative maximum here also. If that means I have relative minimum between 1 and 3, no, because the function may not be continuous. If the function is continuous, yes. So this is false. Yes, we're thinking maybe it will do something like this, since it's a relative maximum. But maybe the function is not continuous. So maybe I stopped here, and then I started from here. I'm doing something like this. Since the function is not continuous. But if the function continuous, yes. Okay. Let me finish my disk with which is similar to this one, but different function. For find values, I have two constant, A and B. And B says that the relative maximum of f is f of 4 equal 2. So I have the point 4 and 2, which means f of 4 equals 2. I have relative maximum, it means f prime at 4 equals 0. These are the two conditions which I have. Now I need to do the calculations. F of x equal a x e b x squared. F prime will be what? It's the product rule. So I have a e b x squared plus ax في e bx squared في 2bx. Okay. That give me what? That give me a bx squared times 1 plus 2bx squared. Okay, that's f prime. Now I will use this. F of 4 equals 2. That means what? This equation I have 2 equal 4 equal 2. F of 4 So it will be 4A E 16B. This is one equation, equation 1. Equation 2 comes from where? F prime at 4 equal to 0, since I have relative maximum. That give me what? For this one, I can simplify as 2A equal 1 over e to the power 16B. So A equal half e minus 16B. This is A in terms of B. Okay, F prime at 4 equals 0. That implies what? A E 16B times 1 plus 32. Here, what's 2 times 16 plus 32B equals 0. So for sure, here A not equal to 0. So this is not equal to 0. This is not equal to 0. So that means 1 plus 32 will be equal to 0. So B equal what? Minus 1 over 32. So it will be A. A will be half E minus 16 half. B, I'll plug B here. E to the power half. So that give me what? A equal square root E over 2. So it will be the function. The function will be A, which is square root E over 2, times X, times E to the power B, which is minus X squared over 32. That would be my function. Yeah, I think this is the end of it. I think we did more than enough problems for this section. Let me stop the recording. Stop recording.